Welcome to MRL. In this learning session, we'll be learning about the mathematical operations on algebraic expressions. In this part, which is the second part, we'll be learning the division of polynomials and so on. Now, division of a polynomial by a monomial. So I have taken the first case, division of a polynomial by a monomial. Now we have let us consider an example here. We have about 8x cubed minus 16x squared plus 24x divided by 8x. We have a trinomial here and a monomial. So the trinomial is the numerator, the monomial is the denominator. When we have a polynomial in the numerator, then convert it into monomial by monomial first. So it will be dividing 8x cubed by 8x minus 16x cubed by 8x plus 24x by 8x. Please remember that. Now then if you look at the monomial by monomial, follow the rules of monomial by monomial, that is divide the signs, divide the numerical coefficients and divide the variables using the laws of indices, that is a by a raised to m by a raised to n is a raised to m minus n. That is therefore we have plus divided by plus is plus, 8 by 8 x cube divided by x will be x raised to 3 minus 1. Then again here we have minus, then 16 by 8 x raised to 2 minus 1 and 24 by 8 x raised to 1 minus 1. Now here plus divided by plus is plus, 8 divided by 8 gets cancelled here, x raised to 3 minus 1 is x square. Then we have minus 16 by 8 is 2, x raised to 2 minus 1 is x, and 24 when divided by 8, 8 3 is 24 and x raised to 0, that is 3x raised to 0. So therefore we have x square minus 2x plus 3 into 1, because anything raised to 0 is 1. Therefore the answer is x square minus 2x plus 3, and this is how we divide a polynomial by a monomial. Please remember the rules of division. So first of all, if numerator is a polynomial, divide each term by the denominator. Follow the rules of division of monomial by monomial. Divide the signs, divide the coefficients, divide the variables using the relation a raised to m by a raised to n is a raised to m minus n, and a raised to 0 is equal to 1, and so on. So that is what is the division of polynomial by a monomial. Now division of polynomial by binomial. Now here we will be learning the long division method. Now what is this long division method of dividing a polynomial by a binomial, or division of a polynomial by a polynomial? So the first step is write the trinomial x square plus 4x minus 5 in standard form, that is in the decreasing order of variables, which is correct here, x raised to 2 plus 4x minus 5, and write it underneath under the what you call a horizontal line, and put the what you call the parenthesis here, and take x minus 1 as the divisor. So we have the dividend x square plus 4x minus 5 is a dividend polynomial, and that is a divisor polynomial. Now start dividing x square plus 4x minus 5 by x minus 1, and the procedure is divide x square by x. Divide x square by x will get x. So we get x here, and then multiply that x with x minus 1. So x into x minus 1 becomes x square minus x. So write here x square minus x. Now x square and x square will cancel, and 4x then subtraction means change the sign here, plus 4x plus x becomes 5x, and bring minus 5 down. So please remember, always eliminate the first term of the dividend. So to eliminate the dividend, that is x square, we have to multiply x with x, that becomes x square, and then we have to multiply minus 1 with x, we get minus x, and subtraction means change the signs, and we get 5x here, bring minus 5 down again. So follow the same procedure. We have to eliminate 5x here. To eliminate 5x, multiply x with plus 5. So plus into 5 into x becomes plus 5x here, and minus into plus becomes minus 5 on the 5. Now subtraction means change the signs, 5x minus 5 becomes 0, and minus 5 plus 5 becomes 0. The remainder is 0. So we have the quotient as x plus 5 and the remainder as 0. So that is the procedure of long division method. Now again let us take one more example here. We have a polynomial here, which is a dividend, and a trinomial, which is the divisor. So write the dividend in parenthesis with the horizontal on the top, and then take the dividend. Now again the procedure is eliminate the first term. To eliminate the first term, I have to multiply x square is with the 3x. So 3x into x square becomes 3x cube. Please remember this, 3x into x square is 3x cube. I have taken 3x here because when I multiply with x square I get 3x cube, which because I have to eliminate the first term. Once I get the first term as 3x cube, then multiply 3x with the second term. Minus into plus is minus, 3 into 3 is 9, x into is x square. Multiply 3x with plus 5, that becomes 15x. Now subtract it. Now when I subtract means change the sign, so this becomes minus, plus and minus, so this will cancel. We will get minus 13 plus 9 becomes minus 4x square, and plus 27 minus 15x becomes plus 12x. Bring minus 20 down. Now I have to eliminate minus 4x square, so I have to multiply x square with minus 4. Minus into plus is minus, 4 into x square is 4x square, minus into minus is plus, 4 into 3 is 12x, minus into plus is minus, 4 into 5 is 20. Now change the signs, subtract for change the sign and subtract it. Minus 4 plus 4 becomes 0, plus 12 minus 12 becomes 0, minus 20 plus 20 becomes 0, the remainder is 0. Therefore, the dividing polynomial by a trinomial here, we get the quotient as 3x minus 4 and the remainder is 0. So this is a very important method of division of polynomials, which is we follow here the division algorithm of polynomials. Please remember this. Now the next important study is finding value of an algebraic expression given values of variables. Now here we have given a is 11 and we have to find the value of this algebraic expression. So first let us simplify this. A cube plus 4a square minus 10 becomes a cube, plus into plus is plus, 4a into a square, plus into minus is minus, 4 into 10 into a. So it is a cube plus 4a cube minus 40a, and wherever a is there, put that means we simplify this. For a cube plus 4a cube becomes 5a cube minus 40a, and where a is there, put a is equal to 11. So it is 5 into 11 cube minus 40 into 11, 5 into 1331 minus 40 into 11. Simplification gives us 6215. So that is how we find out the value of an algebraic expression for any given value of a variable. Remember that. Now what are the uses of algebraic expressions? Very important here. Now the first important use is to frame a formula or to find a formula. For example, if you want to generalize the formula to find the area of a rectangle, then take the length of the rectangle as L, the breadth as B, then the product of length into breadth gives us what you call the area, that is the area is L into B. Now if you want to find the perimeter, we know that in a rectangle opposite sides are equal. If that means the two sides, opposite sides is L plus L, 2L, B plus B is 2B. Therefore the generalization is of the perimeter is 2 in the bracket L plus B. So that is the first important application of algebraic expressions in geometry. Of course in mathematics. General term of number patterns. Now we have a pattern here, 2, 4, 6, 8 are even numbers. 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8, they are even numbers. Now if you want to generalize it, then we can take the generalization will be 2n, n is a variable, because when I put n is equal to 1 we get 2, n is to 2 is 4, n is 3 is 6, n is 4 is 8, n is 5 is 10, and that is the generalization or general term of any pattern of numbers. Similarly, one more example here, 1, 3, 5, 7, 1, 3, 5, 7, they are all odd numbers. 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7. So we can generalize this or get a general term. Take 2n plus 1, n is a variable, put n is equal to 0, then it becomes 1, put n is equal to 1, then it is 2 into 1 is 2 plus 1 3, n is equal to 2, 2 into 2 is 4 plus 1 5, so that is the general term of this number pattern. So therefore the algebraic expressions can be used to write the general term of any given number pattern, and very useful in various different types of progressions which you'll be learning in your higher classes. Now formula for repeated shapes. Now we have the shapes here. We have formed a square with 4 sticks, and 2 squares with 4 plus 3 7 sticks, and 3 squares with that is 3 plus 3 6 plus 3 9 plus 1, so sticks like that, 10 sticks. Now if you want to generalize that, let us assume that n is equal to 1 and the generalization is 3n plus 1. Put n is equal to 1, n is the number, please remember n is a variable, and therefore I can put n as 1. 3 into 1 is 3 plus 1 is 4, 4 sticks, so 1 square will get 4 sticks. 2 squares is 3 into 2 is 6, 6 plus 1 is 7, 3 sticks, 3 into 3, n is 3, 3 into 3 is 9 plus 1, 10. So therefore we can also write the formula for repeated shapes. Remember that. Now instead of n is equal to 3, if I take n is equal to 4, then it will be 4 into 3 is 12 plus 1, that is 13. So 4 squares will have 13 sticks. So that is how we can generalize the formula for repeated shapes also. And also, if you observe here in this, the geometrical pattern, we have a rectangle. There is only one diagonal from one vertex, from the vertex A, and this is what you call pentagon. There are two diagonals from vertex B, and this is a hexagon. There are three diagonals from vertex B. Now that means if there are four sides, there is one diagonal. If there are five sides, there are two diagonals from a vertex, and if there are five sides, then there are three diagonals from a vertex, and we can generalize this. If there are n sides, then the number of diagonals will be n minus 3. So that is the generalization of geometrical patterns. n minus 3, 4 sides, 4 minus 3, 1 diagonal. 5 sides, 5 minus 3, 2 diagonals. 6 sides, 6 minus 3, that is 3 diagonals. So that is how we can write the various geometrical patterns to find out the types, number of diagonals, and so on. So that is how we can use algebraic expression for different purposes.